In this video, we will learn about radicals and how to evaluate radical expressions. Radical expressions are basically exponential expressions with a fraction exponent. For example, the base x here is raised to the exponent a divided by b, or a over b. So the exponent is a fraction. Now we can rewrite this exponential expression into this radical expression, which is read as the bth root of x to the a. Now in this radical expression, b, which is written on the upper left of the radical symbol or radical sign, is what we call the index. X to the a, which is the expression inside the radical sign, is the radicand. And of course, a is the exponent of the variable in the radicand. Now, how do we evaluate radical expressions, or how do we get the indicated root? First, we simply divide the exponent of each number or variable in the radicand by the index. So we have to consider each number or variable separately. Then we have to divide the exponent of each variable or number by the given index. Now, if there is a remainder in dividing the exponent by the index, we have to leave that remainder inside the radical sign or radical symbol. Now, of course, we have to remember that we can also use the laws or roots of exponents in simplifying radical expressions. Now, let's evaluate some radical expressions. First, let's say we have the square root of x to the 14. Now, remember, if no number is written as the index is actually 2 because this is the square root. So how do we evaluate this expression? We simply divide this exponent by the index. So we have x to the exponent 14, the original exponent. Then we have to divide that exponent by 2. So 14 divided by 2 is 7. Therefore, the square root is x to the 7. How about the cube root of y to the 15? How do we get the root? We simply divide the exponent by the index. So we copy the base y, or the variable y. Then we now have 15. Divide that exponent by the index 3. So we can simplify that into y to the 15 divided by 3 is 5. Next, what is the fourth root of p to the 21? So how do we get the fourth root? We simply divide the exponent by the given index. So we have p to the exponent 21, divide that exponent by the index 4. Okay, so we have p. What is 21 divided by 4? Of course, that is 5, remainder 1. Therefore, outside the radical symbol, we now have p to the 5. And then since we have a remainder of 1, we have to multiply this by the fourth root, because again we are getting the fourth root of p to the 1, or simply the fourth root of p. Next, we have the square root of 49z to the 11. So in this case, we have a number 49 and a variable. We have to consider the number and the variable separately. So, and yes, we have to divide the exponent of each number or variable by the index. Okay, so since we are getting the square root, we can express 49 as a square, and we know that 49 is 7 times 7, so that is equal to 7 squared. Then we copy z to the 11. So how do we get the square root? So we now have, so first we have 7 squared, so 7 to the exponent 2, and to get the square root, we divide that exponent by 2. Okay, next we have z to the 11. So z to the exponent 11, To get the square root, we divide that exponent by 2. Let's simplify this expression. So 7 to the 2 divided by 2 is 7 to the 1, or simply 7. 7 to the 11 divided by 2. 11 divided by 2 is 5. Remainder 1. Okay, so how do we write the final answer? We have 7, copy 7. Then outside the radical symbol, we have z to the 5. So z to the 5. Since we have a remainder of 1, we have to multiply this expression by the square root. Since we have, again, the square root in the first place, the square root of z to the 1, or the square root of z. Next, we have the cube root of m to the 10 and to the 21. How do we get the cube root? We divide the exponent of each variable by the index 3. So we have m to the 10, exponent 10, divided by the index 3. Then times n to the exponent 21, divided by the index 3. Let's simplify the exponents. M to the 10 divided by 3 is 3, remainder 1. 21 divided by 3 is 7. So outside the radical symbol, we have m cubed times n to the 7. But for m, we have a remainder 1. So we have to multiply this expression by the cube root, because remember, we are getting the cube roots. The cube root of m to the 1, or the cube root of m. Next, we have the fourth root of 16, p to the 9, q to the 18. Since we are getting the fourth root, we can write 16 into 2 to the 4. 2 times 2 is 2, 2 times 2 is 4, times 2 is 8, times 2 is 16. Therefore, 16 is equal to 2 to the 4. Then we copy p to the 9 and q to the 18. To evaluate the fourth root, or to get the fourth root, we have to divide the exponent of each variable or number by the index 4. So 2 to the 4 divided by the index 4. Next, p to the 9, p to the exponent 9 divided by the index 4. Times q to the exponent 18 divided by the index 4. Let's simplify the exponents. Okay, 4 divided by 4 is 1, so the number becomes 2 to the 1, or simply 2. Then we have 9 divided by 4. That, of course, is 2, remainder 1. Then for q, we have 18 divided by 4. That is 4, remainder 2. So outside the radical symbol, we have 2p squared times q to the 4. But for p, we have a remainder of 1, and for q, we have a remainder of 2. So we have to multiply this expression by the fourth root, because again, this problem is getting the fourth root. So the fourth root of p to the remainder 1, so p to the 1, or p, times q, we have a remainder of 2, so times q squared. Next problem, we have the fifth root of a to the 19, b to the 25. So to get the fifth root, we simply divide the exponent of each variable by the index 5. So we have a to the exponent 19 divided by the index 5 times b to the exponent 25 divided by the index 5. So let's simplify the exponents. We have a to the 19 divided by 5 is 3 remainder 4 times b to the 25 divided by 5 is 5. So outside the radical symbol, we have a cube. So write a cube, and b to the 5. So times b to the 5. Since for the variable a, we have a we have a remainder of 4. We have to multiply this expression by the fifth root, because of course we are getting the fifth root in this problem. So the fifth root of a, since the remainder is 4, the fifth root of a to the 4. Lastly, how do we get the sixth root of x to the 12, y to the 7, z to the 9? We simply divide the exponent of each variable by the index 6. So we have x to the 12, exponent 12, divided by the index 6, times y to the exponent 7, divided by the index 6, times z to the exponent 9, divided by the index 6. Let's simplify the exponents. 12 divided by 6 is 2. 7 divided by 6 is 1, remainder 1. 9 divided by 6 is 1, remainder 3. So outside the radical symbol, we have x squared, so copy that, times y to the 1, or simply y, times z to the 1, or simply z. Now, since there are remainders for y and z, we have to multiply this expression by the sixth root because we are getting the sixth root. The sixth root of y, since there is a remainder of 1 for y, the sixth root of y times, since there is a remainder of 3 for z, times z to the 3. So we have the sixth root of y, z to the 3. If you have any question, please leave a comment.